Welcome to Tungal online classes. In the last class, we completed the numericals of the Newton laws of motion. Today, we are going to start the new topic, that is Newton laws of motion part 2 or friction. So, already we discussed about the contact forces. When the contact forces will be developed, whenever a given object is placed on the given horizontal surface. So, let us consider object of mass m is placed on the horizontal surface. Whenever the block is in contact with the contact surface, between the block and the contact surfaces, the contact forces are developed. These contact forces are mainly classified into two different categories. One of the forces is calling as the normal reaction and the another force is called what? Friction. And here, initially we are assuming that the given block will be in the state of the rest. The given block will be in the state of the rest over the surface of rough horizontal surface. Which type of surface here we consider? Rough horizontal surface. Initially the object will be in the state of the rest, and in the initial condition we didn't apply any external force. We didn't apply any external force over the given object. Whenever we didn't apply any external force over the given object, out of the two contact forces, one contact force will be existed. That contact force is nothing but normal reaction. So already we told the contact forces are mainly classified in two different categories. One of the contact force is called a normal reaction and the other force is called what? Friction. So whenever the block will be in the state of the rest and we didn't apply any external force over the given object, the normal reaction will be existed. Normal reaction is always acting perpendicular to the surface of the contact. Next, when we didn't apply any external force over the given object, the frictional force does not be arises. When the frictional force will be comes to play, whenever the frictional force will be active means when you apply an external force and when you try to pull the given object, at that instant only frictional force will be developed. So initially the object itself will be in the state of the rest and you didn't apply any external force over the given object. So in this particular case, the frictional force value will be is equal to 0. It is a very important point. Whenever there is no external force is acting on the given object, the frictional force does not be existed between the given object as well as the given contact surface. Now, what we are assuming that? We are assuming that by applying some external force, in this case, the external force value is not is equal to 0. In this case, by applying some external force, we try to pull the object. Whenever you try to pull the object between the given object as well as the contact surface, the frictional force will be arises. The frictional force is always opposes the relative motion between the object and the contact surface. What is that? Frictional force is always opposes the relative motion between the object as well as the contact surface. So this point is a very important. Frictional force always opposes the relative motion only. Frictional force is always opposes which type of motion? Relative motion between the given object as well as the contact surface. So whenever we apply some external force, the frictional force will be developed. So here already we know that the frictional force will be existed in three different cases. So what is that? The frictional force are mainly classified into three different categories. The first one is what? Static friction. First frictional force is what? Static friction. Second one is what? Kinetic friction, and the third one is what? Rolling friction. The frictional forces are mainly classified into three different categories. What are they? Static friction, kinetic friction and rolling friction. When the static friction will be existing between the given surface means, suppose here whatever the block we assume that is placed on the given horizontal surface. To bring the object into the motion, for example, 100 newtons is required. What I am saying here? To bring the block into the motion, what amount of force is required? 100 newtons will be applied. When you applied 100 newtons amount of the force only, then only the block will be coming into the motion. So here, that a minimum force is required to bring the object into the motion will be calling as the limiting friction. So how can we define the limiting friction value? That is the maximum amount of the static friction, or minimum amount of the external force. maximum amount of the static friction or minimum amount of the external force that is required to bring the block into the motion. So, how can we define? It is either maximum static frictional force or minimum external force which is required to bring the object into the motion. Such type of force we are calling as what? Limiting friction. So to solve the numericals in the case of the friction, first whatever the numerical they given, first you calculate the limiting friction value. Without knowing the limiting friction, you can't state the motion of the object. Now, once you decide the limiting friction value, how can we calculate the limiting friction value? Limiting friction value is equal to mu s into n. Limiting friction value is equal to what? Mu s into n, where mu s is indicating what? Coefficient of the static friction, n is indicating what? Normal reaction. So in this case, if the object will be placed on the horizontal surface, the normal reaction value is equal to mg. Normal reaction value is equal to what? Mg. So in this case, the limiting friction value is equal to what? Mu s into mg. Let it be the equation number 1. So this is a required force. Before going to calculating the numericals, we have to know. So here, if the applied force, F external force value will be less than the limiting friction, So once you calculate the limiting friction value, now whenever we applying some external force which is the less than the limiting friction, in this case the body does not slides. When the body does not slides, whenever the applied force value will be the less than the limiting friction, then the body does not slides. Whenever the body does not slides means, in this case, the frictional force value is equal to what? Applied force. Frictional force is equal to what? Applied force. So whenever the body will be in the state of the rest, at that time the body will be does not slide. Whenever the body does not slide, the frictional force value will be equal to what? Applied force. Next, if the applied force value is equal to external force value is equal to what? Limiting friction. If the applied force value is equal to what? Limiting friction, then the body will be tends to slide. So whenever the applied force value will be is equal to the limiting friction value, that is the minimum force that is required to bring the object into the motion, at that time the body will be tends to slide. In this case, the frictional force value is equal to either limiting friction or F applied. So in this case, the body will be tends to slide. That should not be in the motion, but it is ready to move. Next, in the third case, if the applied force value will be greater than the limiting friction, in this case the body will be in the motion. So whenever the body will be in the motion, which type of friction was existed means that a friction will be calling as a what? Either kinetic friction or dynamic friction. So whenever the applied force value will be greater than the limiting friction, the corresponding frictional force will be calling as a what? Kinetic friction. The corresponding friction is equal to what? Kinetic friction. The kinetic frictional force will be represented by F suffix k. So in this case, the object will be in the motion. So in this case, the frictional force value equal to what? Frictional force value is equal to kinetic friction, that value is equal to mu k into n. So this is the basic information about the frictional force. Next, loss of friction. In the loss of the friction, whether the body will be in the state of the rest, it is in the motion or it is in the rolling, the frictional force is always directly proportional to the normal reaction. The frictional force is always what? Directly proportional to the normal reaction. To remove the proportionality, we are introducing some constant value. That constant value will be taken as mu. What is the mu here? Mu will be calling as coefficient of the friction. So, what is the first law of the friction? The frictional force is directly proportional to what? Normal reaction. To remove the proportionality, we introduce one constant. That constant value is anything but what? Coefficient of the friction. So, in the case of the, remember, static friction as well as the kinetic friction. In the case of the static friction and kinetic friction, the frictional force is independent of area of the contact. Frictional force is what? Independent of the area of the contact. In which cases only? In static, kinetic frictions. Static, kinetic friction. The frictional force F is independent of area of contact. The frictional force is what? Independent of the area of the contact. But when you consider the rolling friction, when the rolling friction will be arises, whenever the body will be rolls, like a vehicle will be traveling on the road, between the rolling tire and the road, the rolling friction will be existed. In the case of the rolling friction, frictional force is depends upon the area of cross section. So, in a rolling friction, the frictional force will be depends upon the area of the contact. So, these are the laws of the friction. Next, if we assume F suffix S is indicating the static frictional force, Fk will be indicating the kinetic frictional force, Fr will be indicating the rolling friction. So, between them one relation will be there. Static frictional force is the static frictional force value will be greater than the kinetic friction. Kinetic friction is always greater than the rolling friction. So, what is the relation between the static friction, kinetic friction and rolling friction? Means static frictional force is the maximum frictional force, so that static frictional force is always greater than the kinetic friction, which is greater than the rolling friction. If the relation will be existed like that, we also write mu suffix S is greater than mu suffix K, which is greater than mu suffix R. What is the mu S? Coefficient of the static friction is greater than coefficient of the kinetic friction, which is also greater than coefficient of the rolling friction. So that the maximum frictional force is the what? Static friction, and the minimum frictional force is the what? Rolling friction. Okay. So this is the basic relations and the basic information about the friction concept. Angle of friction. See here we consider an object which is placed on the rough horizontal surface. So, whenever the object is placed on the rough horizontal surface, already we told contact forces are existed. So, one of the contact force is acting perpendicular to the surface of the contact, and the another contact force, that is nothing but friction. Friction is always acting tangential to the surface of the contact. So, F, N are indicating what? Contact forces. If you calculate the resultant contact force, the resultant contact force is always lies in between the normal reaction as well as the frictional force. So, in the given diagram, R is indicating what? That is a resultant contact force. Resultant contact force is always existed in between the normal reaction as well as the friction. Now, how can we define the angle of friction? Means the angle of friction is defined as the angle made by the resultant contact force with respect to the normal reaction. The angle made by the resultant contact force with respect to the normal reaction, that angle we are calling as a what? Angle of friction. According to the vector laws of addition, in this direction if a force is represented, if the parallel vector if you taken like this, it is also indicating what? Friction. From the right angle triangle, if you write tan theta is equal to opposite force by adjacent force, tan theta is equal to what? F by n. So, in the place of the theta what we are placed? Phi. Tan phi is equal to what? F by n. Already you know that F is equal to what? Mu into n, again by n will be getting cancelled. Therefore, mu is equal to tan phi. Important relation. Mu is equal to what? Tan phi. What is the mu denotes? Mu is denoting what? Coefficient of friction. That is present between the given body and contact surface. So, The coefficient of friction mu is depends upon the water nature of the contact surface. Nature of the contact surface. So this is the relation in between coefficient of the friction to the angle of the friction. And from this figure also we are calculating the resultant contact force. Here n comma f will be acting right angles to each other, so that the resultant contact force will be given by resultant contact force is equal to what? Under root of f square plus n square. F square plus n square. Already you know that f is equal to mu n. So if you substitute that, it is the value of mu square into n square plus n square. What is the resultant contact force? Under root of f square plus n square. So here I will substitute the value of f, that is equal to what? Mu square n square plus n square. Mu square n square plus n square. Therefore r is equal to n square will be the common, so that it becomes to what? N into under root of 1 plus mu square. N into what? Under root of 1 plus mu square. From this diagram, normal reaction value is equal to weight of the block. Normal reaction value is equal to what? Weight of the block, and under root of 1 plus mu. Mu is equal to, already you know that the formula tan theta. So 1 plus tan square phi. So this value becomes to what? Mg into sec phi. So this is the another expression for the resultant contact force. Another expression for the resultant contact force. Like this we have to calculate angle of friction as well as the resultant contact force. And the next concept is motion on a horizontal rough surface. So next concept is what? Motion on a rough horizontal surface. Motion on a rough horizontal surface. See here, we consider the rough horizontal surface. We consider what? Rough horizontal surface. Over the rough horizontal surface, we place a block of mass m. We place the block of mass m. Already we discussed three different cases. What are the three different cases? In the case 1, if the applied force is equal to 0, frictional force is equal to 0. So what is the case 1 here? If the applied force is equal to 0, applied force is equal to 0, frictional force is equal to 0, frictional force is equal to 0. So in this case, the body does not move, it is in the state of the rest. Next, whenever the applied force value is equal to, whenever the applied force value is equal to limiting friction, whenever the applied force value is equal to what? Limiting friction. In this case, the body tends to move. In this case, the body tends to move, and we consider the case 3. So what is the case 3? If F applied is greater than the F limiting. If the F applied is greater than what? F limiting. What is already we discussed? The body will be in the motion. So whenever the body will be in the motion, so the frictional force becomes to what? Kinetic friction. Already I told. Whenever the object will be came into the motion, the static frictional force will be converted into what? Kinetic friction. So that over the given object along the tangential direction, kinetic friction will be acting, and the external force will be acting on the body continuously. So whenever the body will be in the motion, the object will be having some acceleration. Here we are going to calculate the resultant acceleration of the moving block or sliding block. So here, whenever the object will be in the motion and two different forces are acting over it, so that net force acting on the block is equal to F net is equal to F external minus frictional force. F net is equal to what? F external minus F frictional force. Here, according to the Newton's second law again, F net is equal to what? Mass into acceleration of the block. Mass into what? Acceleration of the block. So F external is equal to, let it be F, and frictional force is equal to what? Mu k into n. Mu k into n. So since the surface will be the horizontal surface, normal reaction value is equal to mg. So that if you calculate the acceleration value, mu k into normal reaction value is equal to what? Mg. Therefore, acceleration of the block is equal to F by m minus mu k into g. Mu k into g. So this is the motion of the block along the horizontal rough surface. Like this we have to calculate the acceleration of the block. A body is kept in contact with the vertical surface. A body kept in contact with the vertical surface. Whenever the body will be kept in contact with the vertical surface, so one thing is clear, the weight of the block will be acting vertically downwards. Weight of the block will be acting in the vertically downward direction. So here let us assume that it is the body which is in contact with the vertical surface. The weight of the block will be acting in the downward direction. If we apply some external force over the object, if we apply some external force over the object which is a perpendicular to the surface of the contact, then only the object will be in the state of the equilibrium. So when the object will be in the equilibrium, we must apply some external force. We must apply some external force over the given object which is in contact with the vertical surface, then only the object will be in the state of the rest. Otherwise, the object will be, if you didn't apply any external force, the object will be sliding downwards. The object will be sliding downwards. So that to keep the object in the state of the equilibrium with respect to the vertical wall, over the object, we apply some external force. According to this given diagram, the applied force is acting on the body, perpendicular to the surface of the contact, So here, if we are assuming that the body will be in the equilibrium condition, already we know that if any one of the body will be said to be in the equilibrium condition, net force acting on the body is equal to 0. Net force acting on the body is equal to 0 means what? Net force acting along the x-axis as well as the net force acting along the y-axis must be equal to 0. First we will consider along the x-axis. So the normal reaction is always acting perpendicular to the surface of the contact and applied force will be along the positive x-axis. From this we will write applied force is balanced by the normal reaction. Applied force is balanced by what? Normal reaction. Next, along the y-axis, the weight of the block is balanced by the frictional force. Why the frictional force is acting in the upward direction? If you remove the applied force, the body will be moving in which direction? Downward direction. If you remove the applied force, the body will be moving in the downward direction. So that its a downward motion will be opposed by the frictional force. That's why the frictional force will be acting upward direction. So that the frictional force will be balancing what? Weight of the block. But we know that what is the frictional force? Frictional force is equal to mu into n. Frictional force is equal to what? Mu into n. So substitute these values here. F is equal to mg. Mu into n is equal to what? Applied force. From this we will write the required expression. Applied force is equal to what? Mg by mu. Applied force is equal to what? Mg by mu. So F is denoting what? The amount of the force required. To keep the block in equilibrium with respect to the vertical wall. So this is the force required to keep the object in the equilibrium condition with respect to the vertical. See here, they given a book. The book is pressed against between our two hands. So in this situation, the book itself will be in the state of the equilibrium due to the equal amount of the forces that are applied by our hands. So that is the application we are going to discuss. See here, initially the book is said to be in the equilibrium condition, so that the weight of the book is balanced by the upward frictional force. So in the previous case, the block will be in contact with respect to only one contact surface. But in this case, the book is kept in contact with the two surfaces of the hand. So that between one hand and the book, one frictional force will be acting. Between the another hand and the book, another frictional force will be acting in the upward direction. So that if the book itself will be in the equilibrium with respect to our hands, so that its weight will be balanced by total the frictional force which is acting in the upward direction. So that mg is equal to, we will write 2 into F. Mg value is equal to what? 2 into F. From this I will write frictional force F is equal to what? Mg by 2. Frictional force F is equal to what? Mg by 2. Next, whenever we are applying the force with the help of the hands, the force which is applied by the one of the hand will be balanced by the normal reaction. So that here the force which is applied by either of the hand will be balanced by the normal reaction which is exerted by the corresponding contact surface. Corresponding contact surface. Once again, see here, whenever we are applying some external force over one side of the book, that respective side will be applying an equal amount of the normal reaction in opposite direction to the applied force. So that in this case we will write F is equal to what? N. Let it be equation number 2. Equation number, see here, we will do the equation by 1 by equation 2. Equation 1 by equation 2. So I am taking that F by N. F by N. So right side we will write N. N is equal to what? F. F by N. So here on the right side mg by 2 by F. Mg by 2 by F. Already we know that what is the F here? F is equal to mu into normal reaction. So that F by N value is equal to what? It is nothing but coefficient of the friction, and this value becomes to what? Mg by 2F. Therefore, F is equal to mg by 2 mu. F is equal to what? Mg by 2 mu. So this is the minimum required force, which is applied by every hand, to keep the block in the rest in between the two hands. This is the another application. Next one, important application. See here, sliding block on a rough horizontal surface, which is coming to the state of the rest. See here, we consider one horizontal surface. At a given instant, a block is having the initial velocity of u. At a given instant, the block is having a velocity of u, and over the given block, frictional force will be acting continuously. Which type of block we consider? We consider a block of mass m, which is having the initial velocity u, that is also already existed in the motion. At that instant, the frictional force acting on the block is F, which is acting towards the right side direction. Whenever the frictional force is acting on the moving object continuously, after some time the block will be coming to the state of the rest. That only case we consider here. So here there is no external force is acting to support the motion of the block, so that after traveling some distance the block will be coming to the state of the rest. So here I am assuming that the final velocity of the block is equal to 0. So before coming to the rest, the block will be traveling some distance. So I want to calculate what is the displacement covered by the object before it was coming to the state of the rest. So here, to calculate the displacement covered by the object, I am applying the work energy theorem. So what is the work energy theorem? Work done by all the forces is equal to what? Change in kinetic energy. Work done by all the forces is equal to what? Change in kinetic energy. Over the given block, how many forces are acting here? 3 different forces are acting. One is the weight acting perpendicular to the surface of the contact vertically in the downward direction, normal reaction perpendicular to the surface, and a frictional force opposite to the motion of the block. So, if you calculate work done by the gravitational force as well as the work done by the normal reaction, that work done value will be equal to 0. Why? The displacement of the block will be in this direction and their forces are perpendicular to the direction of the displacement. Hence, work done by the gravitational as well as normal reaction value is equal to 0. Now, so here the work done by the frictional force value is equal to change in kinetic energy. Only which force will be causing the work is a what? That is nothing but frictional force. So frictional force is acting towards the left and the displacement is acting towards the right, so that work done by the frictional force is always negative. Work done by the frictional force is a what? Negative. So that the work done by the frictional force is equal to minus F into S. Finally, the object will be coming to the state of the rest, so that finally kinetic energy is equal to 0 and it is having some initial velocity, so that initial kinetic energy is equal to what? Minus half mu square. If you simplify, minus will be getting cancelled, so F into S is equal to, you will get half mu square. F into S is equal to what? Half mu square. Already you know that what is the F? F is equal to mu into N. So here F is equal to what? Mu into, in the place of N I will write directly mg, because the surface will be the horizontal surface. So mu into mg into displacement S is equal to, we will write half mu square. Mm getting cancelled. Therefore, displacement covered by the block displacement covered by the block before it was coming to the state of the rest is equal to what? S is equal to u square by 2 mu k into g. Why we place the mu k means the body will be in the motion. Whenever the body will be in the motion, which type of frictional force will be acting? Kinetic friction will be acting. So that displacement covered by the block is equal to what? U square by 2 mu k into g. Equation number 1. Now, I want to calculate the acceleration of the block. I want to calculate the acceleration of the block. So, to calculate the acceleration of the block, I will consider the equation v square minus u square is equal to 2as. V square minus u square is equal to what? 2as. Final velocity is equal to 0 minus u square 2 into a into what is the displacement value? U square by 2 mu k into g. U square by 2 mu k into g. U square will be getting cancelled. 2 will be getting cancelled. Therefore, the acceleration of the sliding block is equal to a is equal to minus mu k into g. A is equal to what? Minus mu k into g. So, this is the second required equation. Now, already they given after what time the block will be coming to the state of the rest. To calculate the time value, I consider the fundamental equation of the motion v is equal to u plus at. V is equal to what? U plus at. Final velocity is equal to 0. 0 is equal to u. A value is equal to what? Minus mu k into g into t. Therefore, u is equal to what? Mu k into g into t. T is equal to u by mu k into g. T is equal to what? U by mu k into g. So, these are the required equations for the displacement, acceleration as well as time taken by the block to come to the rest. This is the important topic. See, the next topic is the insect will be crawling. The insect will be crawling inside the hemispherical bowl. Insect will be crawling inside the hemispherical bowl. Now, we are going to what value? We are going to calculate what value? See here, we are assuming that initially the insect was at the point A. Initially the insect was at the point A. It will be crawling along the surface of the hemispherical bowl. So, we are assuming that it reaches a particular maximum height that is existing at the point B. So, whenever the insect was at the point B, its weight is always acting in the vertically downward direction. So, that this is the weight of the insect which is acting at the point B. And whenever the insect was at the point B, it is in contact with the surface of the hemispherical bowl. As a result, the surface of the hemispherical bowl will be exerting some normal reaction over the insect. So, here this N is representing what? The N is representing the normal reaction which was exerted by the hemispherical bowl. So, here this normal reaction will be balanced by mg cos theta component. So, that the normal reaction which is exerted by the surface of the hemispherical bowl will be balanced by the mg cos theta. Now, if the insect will try to move beyond the point B, along the beyond the point B, it will be sliding down. So that after the point B, the motion will be in the downward direction only. So that its downward motion will be opposed by the frictional force. That's why the frictional force will be acting in that direction. Now, so here the frictional force is balanced by whom? Mg sin theta. Frictional force is balanced by whom? Mg sin theta. Now, what value actually we are going to calculate? We are going to calculate the height value. If you look at the diagram, this is the radius of the hemispherical bowl. So that from the point O to B, this distance is also giving the radius. This O to A will be equal to radius. O to B is also equal to what? Radius. So here, whatever the height that is travelled by the insect will be taken as h, so that this remaining distance value is equal to what? R minus h. So, let the point will be taken as C. From the right angle triangle of OBC, if you write the cos theta value, cos theta is equal to R minus h by R. cos theta is equal to what? Adjacent side by hypotenuse. So that if you simplify this one, you will get 1 minus h by r, 1 minus h by r. Therefore, h by r is equal to 1 minus cos theta. That implies h is equal to r into 1 minus cos theta. H is equal to what? R into 1 minus cos theta. So that is the required expression for the maximum height that is travelled by the insect. Now, from these two equations you will get mu is equal to tan theta. Mu is equal to what? Tan theta. If a mu value is equal to tan theta, tan theta, see here, I will take one right angle triangle. So this is the angle theta. Tan theta is equal to what? Mu, that is opposite side by adjacent side. So the hypotenuse value is equal to under root of 1 plus mu square. Hypotenuse value is equal to what? Under root of 1 plus mu square. So that h value is equal to r into 1 minus cos theta is equal to 1 by under root of, cos theta is equal to what? 1 by under root of 1 plus mu square. So that another formula is what? 1 by under root of 1 plus a mu square value substituted in the place of cos theta. So this is the maximum height that is travelled by the insect inside the hemispherical bowl. It is a very, very important application, accelerating truck. So already we know that non-inertial frame of reference or accelerating frame. If you consider the accelerating frame, in the accelerating frame, which type of forces are developed? If you consider any one of the non-inertial frame, in that non-inertial frame, which type of forces are developed means pseudo forces are developed. Which type of forces are developed? Pseudo forces are developed. How the pseudo forces are existing? How the pseudo forces are acting means, suppose this is the accelerating truck. This accelerating truck will be accelerating towards the left side direction. The accelerating truck was accelerating towards which direction? Left side direction. So whenever the accelerating truck will be accelerating towards the left side direction, the pseudo forces will be acting towards the right side direction. In which direction the pseudo forces will be existed? Towards the right side direction, since the accelerating truck will be accelerating towards the left side direction. Now, in this case, what they are asking? So they given accelerating truck will be accelerating towards the left side direction with an acceleration of small a, So in different cases, you calculate the acceleration of the block, which is placed over the accelerating truck. See here, in the case 1 we are assuming. So whenever the accelerating truck will be accelerating towards the left side direction, over this block, which force will be acting? Pseudo force will be acting. That pseudo force value is equal to what? Mass into acceleration. What is the mass of small m? The mass of small m will be indicating what? Mass of the given block. Where small m is indicating what? Mass of the given block. That means over the given block, some force will be acting. That force is nothing but mg. Again, already we told, whenever we are applying some external force over a given block, whether the block will be coming into the motion or not, that depends upon the limiting frictional force value. So when the block will be came into the motion, whenever the applied force value will be greater than the limiting friction. In the case 1, what I was assuming that whatever the pseudo force was developed, whatever the pseudo force was acting over the given block, that value will be the less than the limiting friction which is existing between this given block and this surface of the contact. So that here the limiting friction are static frictional force will be acting in the left side direction and pseudo force will be acting towards the right side direction. So if the pseudo force value will be less than the limiting friction, the block will be in the state of the rest. The block will be in the state of the rest. So whenever the block will be in the state of the rest, whenever the block will be in the state of the rest, what is the frictional force value? What is the frictional force value? So here the frictional force value is equal to whatever the pseudo force that is acting on the block, that value will be equal to what? Pseudo force. According to the laws of friction, what we will write here, frictional force value is equal to what? Mu s into mg, directly I am writing, because the object will be in the state of the rest, so that which type of friction was existed here, static frictional force will be existing, so that this frictional force value is equal to mu s into mg is equal to, what is the pseudo force magnitude? Ma. So mm getting cancelled, therefore a value is equal to what? Mu s into g. A value is equal to what? Mu s into g. So up to what time the given block will be in the state of the rest means, up to what time the given block will be in the state of the rest means. So if acceleration of the truck will be less than or equal to, if the acceleration of the truck will be less than or equal to mu s into g, up to that time the block does not slides. So that is the condition they given in the first case directly. So to keep the block in the state of the rest, what is the maximum acceleration of the truck? The maximum acceleration of the truck value will be less than or equal to mu s into g, or the maximum value is equal to what? A is equal to mu s into g. So this is a case 1. Next, in case 2, if the pseudo force value will be greater than the limiting friction, whatever the pseudo force will be acting on the block, that will be greater than the limiting friction. So when it is possible, whenever the acceleration of the truck will be increases, automatically the pseudo force value will be increases. So whenever we are accelerating the truck, pseudo force value increases, as well as the block is also came into the motion. So that whenever the pseudo force value will be greater than the limiting friction, what will happen? Now we will discuss. So this is the direction of the pseudo force, and whenever the applied force will be greater than the limiting friction, the block will be came into the motion. Then which type of friction will be existing? Kinetic friction value will be existing. So that here two different forces are acting on the system, so that net force is equal to what? Net force is equal to pulling force minus opposing force. So net force is equal to what? F minus Fk. So here net force is equal to m into a, we have to write m into a. A means what here? Two types of accelerations are there. One is acceleration of the truck. The acceleration of the truck will be taken as a suffix t, and acceleration of the block. So here acceleration of the block will be in this direction, acceleration of the truck will be towards the left side direction. So that F net is equal to mass into acceleration of the block. Next, pseudo force is equal to what we wrote initially? Ma we wrote. Ma. There A is indicating what? A is indicating the acceleration of the truck. Here A is indicating what? Acceleration of the truck. Therefore, in the place of F we will write m into acceleration of the truck minus F suffix k. What is the F suffix k? That is kinetic frictional force. That value is equal to mu k into mg. M value will be getting cancelled. Therefore, the acceleration of the block is equal to what? At minus mu k into g. Acceleration of the block is equal to what? At minus mu k into g. What is the AB is indicating? Here AB denotes what? Acceleration of the block with respect to the truck, with respect to the contact surface where it was placed. It was placed over the surface of the truck. So that whatever the value AB you got, that AB is actually denoting what? AB is denoting the acceleration of the sliding block, with respect to the truck. If you want to calculate the acceleration of the block with respect to the ground, the acceleration of the block with respect to ground will be given by mu k into g. The acceleration of the block with respect to ground is equal to what? Mu k into g. So this is the application of the accelerating. See the next application. It is also the accelerating truck. So here we consider a truck which is accelerating along the horizontal direction. What we consider here? We consider the truck which is acting along the horizontal direction. Whenever you consider the accelerating truck will be acting as a non-inertial frame of reference. Which type of frame of reference? Non-inertial frame of reference. Whenever you consider any one of the non-inertial frame of reference, within the non-inertial frame of reference, which type of forces are existing? Pseudo forces are existing. Which type of forces are existing? Pseudo forces are existing. And these pseudo forces are acting in which direction? And acting over which objects means? Whatever the objects are present within the non-inertial frame of references, over that objects, the pseudo force will be acting in opposite direction to the direction of the motion of the system. So here the truck itself will be accelerating towards the right side direction, so that the pseudo force is acting on the block of mass m. The pseudo force is acting on the block of mass m towards the left side direction, like that the pseudo force will be acting. So actually what we are going to discuss here means, here we consider an object of a mass m which was kept at the front surface of the accelerating truck, So here over the block of mass m, we can't apply any external force, even though you didn't apply any external force, the block itself will be in the state of the rest and it should not be falling downwards. So that to keep the object of a mass m will be stationary with respect to the accelerating truck, what value they are asking means, with what acceleration the truck was accelerated. So for that we are assuming that the required acceleration of the truck is small a. To keep the block will be stationary with respect to the truck. So the pseudo force acting on the block is given by F is equal to ma, that is acting in the opposite direction. And the weight of the block is always acting in the downward direction. And frictional force will be acting along the tangential surface of the contact. Frictional force is acting what? Along the tangential surface of the contact. So which is similar to the block in contact with the vertical surface, what we discussed earlier. So whenever the pseudo force is acting on the block towards the left side direction, that pseudo force is balanced by the normal reaction. That pseudo force value will be balanced by normal reaction. Now we will write F is equal to mg. Frictional force is equal to what? Mg, and the normal reaction will be balancing the pseudo force whose value is equal to ma. Whose value is equal to what? Ma. So equation 1 by 2, F by n is equal to mg by ma. Getting cancelled. F by n is nothing but coefficient of the friction. So therefore mu is equal to g by a. Therefore acceleration of the truck is equal to g by mu. So what is the required acceleration of the truck to keep the object stationary with respect to the accelerating truck means a is equal to what? G by mu. It is a very important application. So that is the what? Accelerating truck concept.